Okay, so database security to complete. As I mentioned, actually in database, so we looked at some brief, we had a quick review on like the relational database and the SQL language just in the morning. And then in database, actually we also have different security issues, and we also have security solutions. And but we don't go through all of them. One reason is due to the time restriction, and another reason is for other security issues like authentication and access control, they will follow the similar approaches we studied in OS. So, for example, you can also define role-based access control in database. So that means you can assign like tables to different roles. You grant access to different roles instead of individual users. You can also have multi-level access control. Right, so you can define the security level, like top secret, secret, confidential, and so on, for different items in a database. You can define it for the entire database. You can define the level for relation. You can also define like for a column, for a row, even for one attribute. You can define the security level. So in this case, if someone who has a low-level access to read the content, then basically the person may not be able to see some of the items. For example, if you have like 5 columns, the top 2 columns are with the top secret, and a person with secret level can only read the other 3 columns. Right? For the last 2 columns, if they are top secret, then basically the person can only see the none, so you can see nothing about the value. Right? So that's about authentication and access control. Right? So, however, so for database, we also have some other security issues. So one of them is how to preserve the secrecy or the privacy of some data. So even though the attacker may can access some public data. For example, some data may not be critical, may not be sensitive, so that anyone can query those data. For example, the statistical data. However, so from the statistical data, maybe sometimes people try to derive sensitive information. So that's the so-called inference. That means you derive sensitive information from non-sensitive data, right? So that's something we also want to prevent. So in this case, so maybe we have some good access control policies preventing the attacker to obtain some internal attacker to obtain some confidential or secret information. But from some public information, like a statistical information, the attacker may still be able to derive some sensitive information. So we want to prevent that kind of inference, right? So that's what we will study in the next class. So we will look at basically we will first look at what is a statistical database. So and why do we need a statistical database? Then how what do we need to protect? And then how there are different types of attacks that can derive sensitive information from non-sensitive one, and then we will look at how to prevent that kind of inference. So what is a statistical database? So essentially the statistical database allows the user to query some statistical data instead of individual data item. Right? So this is required if some individual data item is actually confidential. For example, the salary of an individual staff within a company can be sensitive. However, so the average salary may not be sensitive. So, for example, people can query the auditor or someone in the company. They can query the average salary, but they cannot see the individual salary. On the other hand, of course, for the payroll officer or HR manager, they may be able to see the individual salary. So in this case, we have access control. So some of them can actually only query the non-sensitive information, but other people then will be able to access the sensitive information by applying some access control policies. For example, you can just define a view or interface for a relation. So in this view or interface, so people can only query statistical information, right? So in this case, normal users, they cannot directly query the data, the individual data or accurate data. They can query some statistical data from some interface or some views created. On the other hand, maybe people with authority can still access those sensitive or individual records, right? So that's basically the meaning of a statistical database. So in general, statistical database the data actually, you may have a normal database, but you just create an interface which only allows statistical information to be queried, right? So this is one form of a statistical, one implementation of a statistical database. You still have the individual records there, but you only create the interface that allows people to query statistical information, right? So then the purpose is obvious. We try to protect the secrecy or the confidentiality of the individual records inside the database, right? So what kind of information we want to protect? For example, some information may be sensitive by default, like where you store some weapons, or for example, where does the government store the nuclear weapon or some other weapon, right? So, and then for example, you can also have identity as sensitive information, right? So if you can identify the identity of a spy or informant or some agency, and in this case, this kind of information may also endanger the person, right? So you can also have other confidential data. So for the normal scenarios, the salary is one of the a typical example where we want to restrict the access. So only the payroll officer, they can see all the HR staff, they can see the salary, but other people, they cannot see the individual salary of other people, right? So we may also want to hide the relations between different users or different objects, right? So the type of disclosure, so these are the same as we looked at in the previous part. So we can have exact data, we can have bounds, like negative results, existence, and so on. So all these kind of information, they may contain some private or confidential information, and then we want to prevent the disclosure, right? So again, here are the same some examples, like the type of information that can be leaked, right? So sometimes actually people can, by querying those information, although those information may not be directly linked, so people may be able to obtain some relationship between the data. For example, here is one example, right? So for example, we do not allow the users to query the address of a specific employee. So we try to hide the address, like the home address of a particular employee. However, so you cannot directly query the address by putting this employee ID or employee name as the condition in the predicate. However, so sometimes actually people can still infer the address by making some other query, right? So this actually shows one example where inference can occur, right? So if we can find out there is a 25-year-old female living in a particular address, and then another query revealed that Alice is the only 25-year-old female in the company, then we can infer actually Alice lives in that place, right? So in this case, although the database does not allow us to directly query say the address of Alice. You can also select address from employee where name equal to Alice. You cannot do that because database does not allow. However, you can make some other query, and then you can, by looking at the result of those queries, you can infer. So Alice actually lives at this particular place. So in this case, we have the inference. So inference is you derive some information that is not allowed to directly query, but you derive that information by making some other query which are legal, which are like allowed. Okay, so this is inference. So this is the cartoon about inference. So the cartoon says 40% of the employee they take leave on like Friday and Monday, and that means one employee actually like 40% of the leaves are taken on Monday and Friday, right? So that's basically another simple example to illustrate the idea of inference. Okay. So before we look at some like inference against the statistical database, we may look at some like example for a non-statistical database. That means, for example, if you want to query the number, like the salary of a particular person, right? So in this case, actually, sometimes you may, even though you are not allowed to directly query for a particular like a value, so you can still use a range, right? So you can still use a range to infer, for example, the salary. For example, you can do a binary search type query, so try to locate the salary, right? So that's one example about this kind of inference attack. But this is not against the statistical database, right? So this is a non-statistical, so inference for a non-statistical database. And similarly, so if say, sometimes you can also use some like result returned by the database to obtain information. For example, you can insert, you try to insert some record into a database, and then the database says reject, say this item already exists. So in this case, so you may, basically in this case you can test, okay, this key has already been used by some other record. So by just looking at the result, whether it's rejected or it's accepted, actually sometimes you may tell, you may identify whether, for example, a particular item exists in the system or not. Right, so also the database may have some like constraint. So here is one example, say the manager must between this, the salary of manager must between this range, or say for a particular job, the age must be within a certain range. So there can be some like constraints determined by the database. So in this case, actually, you can use some insert statement and also to identify what is a constraint, right? So say in this kind of example, you can just insert some random data, like a random value for salary. Then by looking at the result, whether it's rejected or it's accepted, then you can identify what is the range. And then subsequently you can, for example, find out, or in this case you can find out like what are the total amount of money paid to all the managers and so on. So this kind of attack can happen also in non-statistical database. Basically, if there is some restriction which does not allow like some information to be queried, but on the other hand, if you have a set of queries for other like you have a set of queries that are allowed, and then from the result of that set of query, you can infer the content that is not allowed to be directly queried, then you successfully perform a so-called inference attack, right? So that's basically the idea. Now let's look at how this kind of inference can be done against the statistical database, right? So in this example, we use this function say count. So this will count the number of records in this table that satisfy this predicate. That means it will count the number of managers, right? So count actually is one of the so-called aggregation function. So this kind of function is basically used in the function we will use in the statistical database, right? Count is one example. There are some other examples. For example, the sum. You can calculate the sum like of all the people, all the salary for all the employees, the average, the mean, and the max, and so on. So these are all the so-called aggregate functions. So if we define some like a views or a database and we can only query this kind of aggregation functions through the view, then essentially we create an interface for a statistical database. That means you are only allowed to query the statistical information, not the accuracy information, right? So here, but the sensitivity level for different aggregation functions can be different. For example, usually the sum, average, these are less sensitive than like the mean and the max. Because if you query the sum, maybe there are like hundreds of employees. If you query the sum, it's difficult to like infer or predict the salary of a particular staff. So if you use sum or average, these are less sensitive. But if you use mean or max, sometimes actually these may leak like confidential information. For example, if you know the boss or the CEO actually received the highest salary, then the maximum actually will reveal the salary of a particular user, for example, the CEO. And then if you know who received the mean salary, then again you can identify the salary of a particular person. However, so in this case, so basically you need some extra information. So if say you don't have a clear picture about the structure, you don't know who is a boss, who is the manager, who is a normal employee, and so on. So if you just query this kind of mean and max, so you may still not be able to identify the individual salary unless you have some external information. If you have external information saying, say Alex is a CEO, then you by querying the max, and then you may know so Alex the salary of Alex, right? So in general, so the sum and the average, they are less sensitive than mean and the max. But depending on the situation, sometimes mean and the max may still hide the salary of an individual user. So this slide shows aggregation functions actually we can use. Many of them we actually don't really use often, but some of them we use quite often. Right, so for the statistical query, they follow this kind of format. So now basically you don't select the particular attribute of a particular item. So you select the aggregate function. You display the aggregate function of a particular column or particular attribute. And then the remaining are the same. So you just replace this part by aggregate function. So you select this one from the table, so where this condition, this predicate is true. Of course, you can also group the output, right? Display the output by different groups. Right, so here shows some explanation, and you should already be familiar with this kind of query if you studied database subject before, right? So some examples here, right? So suppose we have such a table or relation. So this is an employee table. We have the employee number, name, gender, and so on, right? So now this is a statistical query. So select the average salary from employee for a particular like a department. So where department equal to sales and gender equal to female. So then it will calculate the average salary. Of course, now depending on the situation, so I said average is usually less sensitive, but depending on the situation. So say in this department there is only one female employee, then the average or the sum essentially disclose the exact salary of that employee, right? So in this case, depending on how how big the data set is, right? So if the data set is small, then by querying average or sum, you may still learn the individual salary, right? So later we will see actually statistical database, they may put some restriction, say to prevent the disclosure information, they may say, okay, if the query set is the number of records satisfying the list of predicate, if this number is smaller than the threshold, then the query will be rejected. So this is one standard method to prevent the direct disclosure information. So the statistical database usually will have such kind of restriction. Say if the return set contains only a few items, so less than a threshold, then basically the query will be rejected. However, so even we have such kind of restriction, so attacker will still be able to locate the information by constructing some special queries. So if you construct a set of specially crafted queries, you can still obtain information, even there is a restriction on the size of the return set, right? So this is one example. This is another example. You count how many employees with a salary larger than 100,000, right? So this will tell you how many, right? So if you, again, here if it only returns 1, that means you know, if you know who received the highest salary, maybe the CEO, then you know basically the range. So in this case, you do not know the exact salary, but you know the range. You know the CEO has a salary greater than 100,000, but other people they receive salary lower than 100. So here the information can be like a specific value, but it can also be a range, right? So it can also be like whether it exists or not. So this kind of information can all be like sensitive information. Right, so as I said, actually the sensitivity level or classification, so here we use some terms we used before, right? So it can be different. So depending on which aggregate function you use, so min and max usually are less sensitive than, more sensitive than average and sum, right? And also it depends on the returned query set. So if the returned set actually contains less item, then you can immediately infer some information from the statistical data return, right? So the inference is basically derivation of sensitive information from non-sensitive information. Usually we are talking about the statistical information or aggregated information, right? So in this case, so if we can derive sensitive information from some statistical or aggregate data, then we call this kind of attack inference attack. Right, so if say we could query the average or sum of the salary for all employees older than 60. However, so if there is so only one employee which is over 60, so this can be done by using another statistical query. For example, you query the number, you use a count, right? Or you may obtain this information from some external source. So in either way, if you can identify there is only one employee satisfying the condition, then you use the aggregate function, then you identify the sensitive information, the information for this particular person. So in this case, this is also referred to as inference, right? So you can use the external information, or you can use some additional queries, statistical queries, to obtain some other information that can allow the attacker to infer the confidential information. Right, so there are two types of attacks. So I just mentioned these two types of attacks. The direct attack means you directly query the database to obtain this like an extra piece of information. For example, you can use count to identify there is only one female staff in this department. And then you can use average and sum to obtain the information, the exact information of this staff. On the other hand, so if you can access some external information, you obtain some information from external source, then in this case you may save some extra queries required because you already get this information. So you can use that particular information to launch some like aggregate queries or statistical queries, then you can get the information from the result of the queries, right? So in this case, so for example, if you know like a particular staff who lives in a particular like address, then maybe, here basically you can use these two. So this is basically a direct attack. So if you use this query, right? So you use this query. If it shows there is only one actually, say, staff in a particular department, then actually the sum of the salary will be the same as that particular like staff. So in this case, this count actually will tell you the, for example, this is the only record that can satisfy a query. Right? So on the other hand, if you know, say, the previous case, here you use an indirect attack because you don't know the external information, so you use this count to identify there is only one person. Then you can know the salary of that person by querying the sum. And on the other hand, if you know from some external source, like someone is living in a place, or someone is the only male or female employee, or someone is the only person that satisfies some predicate, then in this case, you can directly query the statistical result by using the information you obtain, right? Okay, so as I said, in order to prevent this kind of attacks, so sometimes the statistical database will try to reject a query which only contains a small set of results. But in this case, when you do the query, if there is only one record that will be written, then the statistical database will reject because if there is only one record, then the aggregate data is same as the exact data. So in this case, we can prevent this kind of like trivial attack, right? So this is some sort of trivial attack because if you know there is only one record, or only you know only there are few records, then you can obtain the information trivially. So if say the database basically refuses to answer such kind of query, if the data set contains only small number of outputs, then this attack becomes, so how to obtain information becomes less trivial because you cannot directly obtain the information. However, so in this case, the attacker may still be able to construct a sequence of queries, right? So say now we put a restriction, say if the number of results in the return set is less than 3, then we just reject this query. So suppose we make such a restriction. So this kind of query will no longer work. However, we can still construct a sequence of queries that will work, right? So let's look at this example. Suppose, right? So we know, say again, Mary is employee in the security department, and then we also know Mary is only female, right? So in this case, so now the database will reject if we use directly query, say the sum or average using say the department ID and the gender. And now we can still try to use a set of queries to infer the salary of Mary. So first we can, for example, use a discount to identify how many people in the department. So if the return is 5, so now this query is allowed because the return set contains sufficient data items, right? So if there is only one, it will reject. And now this query returns 5 records satisfying the department, so it will allow. So now the attacker will know there are 5 employees. So now then you can use count again to find how many male staff in the department. So in this case, if we only have the lower bound, so we only say it's a allowed query which returns small set of records, then this one again will be allowed because it will return 4. So 4 is sufficiently large. So that means the database will allow this query to happen. Then it's very simple. You can query the average for all the employees, right? And then you can query the average for all the males, for all the male staff, because all these will be allowed because now the return set contains sufficient record. So in this case, you can easily calculate the salary of Mary, right? So this is the salary because although we specify the lower bound, so in this case we can still use all these queries to identify the information, right? So this is basically a less trivial inference attack. So however, so you may say in this case, I don't just restrict the lower bound, I also restrict the upper bound. So say if the return set contains too many items, then I also reject. Because in this case, if say I put the lower bound as 2, upper bound as say 3, then if you query the first one, it will be rejected because now the return set contains too many items, right? However, so this kind of restriction eventually still will be like bypassed by the attacker if the attacker makes sufficiently many queries, right? So in general, actually the attacker can build something called a tracker. So the tracker basically will track individual records through like a set of records. So in general, we can use a sequence of queries to build a tracker, right? So we can call some queries that allow individual data to be obtained as an individual tracker, but then other queries like a set of queries that can eventually lead to a individual tracker as a general tracker. So basically, tracker is something that can be used by the attacker to infer individual information from the statistical information. Right. So we will look at the tracker example. Right. So in this case, we know that this can suppose we know that the name and the address can uniquely identify employee. Right. So then we can find the salary of the employee in this way. Right. So in this case, what is the individual tracker? The individual tracker is the sum of salary for this particular address. So this is the individual tracker, but this individual tracker will not be allowed. You cannot directly use this individual tracker. The individual tracker means you don't have this or statement here. You don't have this or statement here. So this is the individual tracker, but this one will not work because database will reject. You only query one record. So in order to eventually use such kind of individual tracker, we need to build some sort of general tracker. General tracker is to assist the attacker to locate the answer for the individual tracker. So the general tracker can be built in this way. So you know the query will be rejected if you ask this specific information. But you can add some other condition here to make this set big, right? So you can make this set big, or you can if you say this set is too big, you can add some condition to make the size of the set like in the middle. So anyway, you find a way to make sure the return set will satisfy will not violate the restriction. So it's maybe not too small, or it may be you need to make sure this one is not small, or not too small, or not too big. So you can add some condition. For example, use the or statement to make sure the set actually will pass the restriction. So in this case, basically, assume now we get this value. This is the sum, right? So this is not the salary for John, but we know. So John's salary is in fact included in this value. Then what you can do is to query, for example, another one. Say you use the same individual tracker, but you add another or statement, right? So now this or statement shows the the sum of salary for John and also now managers. Right, so now basically you can see here we have one variable, two variables, three variables, so but we have two equations. So that means we still need one more equation. If we have a three variable and three equations, then we can solve the variables. So now if you say I select the salary for all the employee, then you get the third equation. So three variables, three equations, you can find the salary of John, right? So basically, you can guess the John. So what if John is not a manager? Then you can have another set of general factors which will allow you to identify the salary of John, right? So basically, this is the individual factor, but we are not allowed to directly ask. But we can use some general factors that will eventually lead to the answer for this individual factor. So in general, you can first build the individual factor, and then extend this general individual factor to several general factors. Then the general factors will provide the answer for this individual factor. So that's how we can do it in general. So basically, this is so you have some precise information you want to ask. Now you don't ask this information directly. You build some general factors which will eventually allow you to lead to the answer. So in general, we can have a tracker built like this, right? So you have for example, you have an individual tracker. So this is the information you want to query. But the database will not allow you to do that because the database may have some restriction on the lower bound and upper bound of the number of items in the return set. So in this case, you need to either reduce or enlarge the return set by adding some extra condition. You add some extra condition to enlarge or reduce the size of the size of the return set, right? Then basically by constructing several related queries, then you can find a solution for the individual factor, right? So for example, you can do a query. This is what you want to target, but you can add something else, right? So you can add query 1 as QT or Q1 or Q2. Query 2 is QT or phi T or phi 1, and then query 3 is phi T or phi 3. Query 4 is phi 2 or phi 3. Like this. Eventually, the result will give you some equations, right? So from the equations, then you can solve the unknown variables and find the solution. This is basically what's the solution you need. So this is a general way to build like a tracker. So to track individual information, right? So that's a general example. Example showing how this inference can be achieved by building some trackers. Right, so how to protect against the inference? So there are two classes of solutions. First is to design the database in a way such that the inference is reduced. However, this will affect availability for sure. So if you design the database to reduce the chance of inference, but at the same time it will reduce availability or usability of the system. The second one is to attempt to detect and reject the queries or sequence of queries that can result in inference attempt. Right, so we will look at some examples. For example, in database design, you may split the table into multiple tables, or you can create multiple views of the table and you do access control. For example, similar as in the, if you still remember in the access control, we look at this Chinese wall model, right? So if you remember, Chinese wall model says there is a conflict interest class. So for data items in the same conflict interest class, if you query one of them, you cannot query the other items. So here is similar. You can use some similar idea. That means you design a database, you create individual views. So if you combine all the views, you get the whole database. But if you only look at the individual view, you only get partial view of the database. So now if you can say, I can use the Chinese wall model. So if anyone who access the information in one view, then that person will not be allowed to access the information in another view. So in this case, we can restrict that anyone who can only have a partial view. Of course, in this case, if two users, they collude, then they can still produce the whole view of the database table, right? So this is one way. So if we can have a proper access control, like for example, we can use a Chinese wall model. If we have a proper access control, saying if someone queries this one, then other people cannot query, or this person or other people cannot query other view. Or you can define the roles, like people with this role can query this view, with another role can query another view. But you don't allow, for example, here we also have the mutual exclusive requirement. So people cannot have the view that can allow them to see both, people should not be able to have the permission to view, have the roles that can allow them to see both views, right? So if we apply the access control, something we studied before, then we can reduce this inference, right? So this is one way. But this method, it will reduce the availability, as I mentioned, because now basically you try to restrict all the people can only see some view of the table. And on the other hand, if people collude, actually they will still be able to produce the whole view of the database. For example, this is an example from the textbook. Suppose we have this table, but we don't want people to have the whole view of this table, right? So basically now we can create two subviews, right? So one is to basically we want to stop people to look at the item and the cost. Then we can create two subviews, right? So one is for availability and cost, one is for item and department. So in this case, if say someone can only see the first view, and other people can only see the second view, then they cannot associate the item with the cost, right? So as I said, we can use so-called Chinese wall model, right? So for these two views, if someone has queried one of them, then the access control will disable the person to look at the other one, right? So this is the Chinese wall model we studied. However, so the problem is if say there are two people, one query to see the first view, one query to see the second view, and they combine the two views together, then in this case actually they will still get the whole picture of the database, right? Of course, another way that can somehow address this problem is you can, for the two views, maybe you try to swap the order of the records. So in this case, the two views, although you can see the individual items, but you cannot link them because now the orders are in different, the records are stored in different orders, right? But anyway, so inference may still occur even if you do this kind of access control. So another method is to reject the queries, right? So we identify what are the queries that may lead to inference, individual checker, right? So in this case, we can reject the query, or we try to produce some solution which actually can prevent this kind of inference from happening, right? So the first one is the method we already mentioned. We try to restrict the size of the return set. So when you perform a query, the return set, the satisfying condition, should not be too small or too big. Because if it's too small, it's obvious. Because if it's too small, say containing only one record, then people can immediately tell the sensitive information. But sometimes if the size is too big, it's also not good, because if the size is too big, that means there is only few items left. So the few items left, those are the information you want to query. So in this case, we should prevent the return set to be either too small or too big, right? So that's the restriction. So in general, we can have such like a restriction. Say the returned items, the size of the returned set should be larger than the threshold and greater than n minus the threshold. So n is the total number of records, k is basically the threshold, right? So the return set should be larger than this threshold and less than. That means when you query the item, query the items, so the return set should be not be small, should not be smaller than k, and also the set remaining. So the remaining set that means the set that is not returned should also not be too small. That means it should also contain at least k items. So that means the queried set cannot be too large. So in this case, we make sure the return set or the remaining set left, both sets actually contain sufficiently many records. So in this case, we can somehow prevent the inference. So at least we can prevent some trivial inference attacks. So some trivial inference attack will not work, but some advanced attack may still work. For example, by building some general trackers. And then the second approach is data perturbation. This data perturbation means we try to perturbate the data within the database, right? So in this case, actually, we try to maintain accurate statistical database, but we actually don't maintain the. So this can be done. For example, you can make a copy of database, but now you change you do the perturbation on the internal data, and then the statistical interface will be associated with this perturbated database. So in this case, actually, the statistical information will be accurate, but the individual information, they are wrong. So one simple way, to give you a simple example, you can swap the data. For example, for different records, like the salary, you can swap the salary of different people in modified in this duplicated database. Then you only allow statistical query to perform on this duplicated database. Then in this case, the statistical data is still correct. You query mean, max, average, sum, so all the data are correct. But when you try to infer the individual record, the data is wrong because you swap the salary of different people in the table. So only the statistical data is accurate, but the actual data is incorrect. Right. So this is one method. This is called data swapping. So this is one type of perturbation that we can do. Alright, so the other one is so-called output perturbation. Output perturbation is we try to do some operation on the return data. Right, so we don't swap the internal data, or we don't make a duplicated database with swap data, but we try to do some process on the return data. Right, so one method is, for example, you can do the sampling. Right, so instead of using the whole set, you sample you make a large sample of the records, and then you calculate the statistics based on the sample. So if the sample is large, then essentially the statistical data will be close to the accurate, the actual statistical data. Similar as in assignment 3, you use some theoretical distribution to simulate the events. So when you use the simulated events to calculate the base profile, so the base profile should be close to the theoretical result. That means the experiment distribution, the distribution for the experiment should be close to the accurate distribution. However, so now the statistical information is close, but the individual data, they are incomplete because you only sample some of the data items. So in this case, but we need to basically, for all these kind of perturbation, data perturbation or output perturbation, we need to inform the users. So the statistical data may not be 100% accurate. So the user must be aware of this kind of information. So they need to be aware that the returned statistical data is not 100% accurate. It's close, but it's not 100% accurate. So the user need to be aware of this kind of information. Right, so that's for the secure statistical database. Basically, this is something beyond the access control. We can do the access control as in the operating system. We can assign like the roles to users. We can grant the access. We can also assign the labels, and so on. But beside the access control, we can also have inference. Inference is some other security issue we need to pay attention.